Hello, math lovers. Welcome back to the channel, Something Rational again. So we have been solving NJSLA release item questions about quadratic functions and their features. So here is one of the questions. You feel free to pause the video first. Then we will come back to you and we will solve the question together. So here in this question, function of f of x given to us. Okay, so function of f of x given to even you can write it, or you don't need to write it because when there is a transformation of the functions, we do it from the vertex. Okay, we pull or push or just like the graph from its vertex. What is the vertex of this function? Vertex of this function is here. Even you don't know the coordinate, no problem, because here I have a new function. Okay, I have a new function which is f of x plus 3 plus 2. So with this new function, I need to know only what kind of transformation it is here. Okay, so if you know the transformation from its vertex of the original function, I can move it, then we can decide the new location of the new vertex. Okay, so as you see here, in general, when we think about the transformation, so this one, let me just this one x plus 3, this one is horizontal shift. Okay, horizontal shift. We already just explains. And this two related to vertical shift. Okay, vertical shift, vertical shift. Actually, this graph means the new graph means 3 units on the horizontal shift, 3 units left or right, 2 units up and down. As we just discussed already, if it is plus 2, it is 2 units up. Okay, 2 units upward, 2 units upward. So it means that your f of x graph will go 2 units upward. Then plus 3 means, we already discussed this, plus 3 when in the parentheses, that is reverse operation. So not 3 units right, 3 units left, okay? 3 units left, 3 units left shift. So since we understand the transformation, which means the new graph will be 3 units left shift from the original graph and 2 units upward from the original graph. So let's start from its vertex, and I need to shift this vertex 3 units left. Okay, this vertex one step, second step, third step. Now this is 3 units left. Okay, this is 3 units left, three left. But 2 units upward, I need to shift those. From this point, 2 units upward, one step. And when I go second step, I am here now. It means that from vertex, you can draw your new graph. Okay. Maybe my graph is not accurate, but you can know this. Okay. My graph is not accurate. You can know this. So we will obtain new vertex, which is at -4 and +1. Okay, we will obtain the new vertex from. So here is just like another view, just or another approach to this question. If calculator is allowed to us, if calculator allowed to us, so we can guess f of x, equation of f of x. What is f of equation of f of x? Okay, here is vertexes at -1 and -1. Okay, if we have a vertex at -1 and -1. Okay, we can write this graph. Actually, we consider f of x is equal to x squared from the just parent function. Vertex is at -1, -1. So x -1 is becoming +1 square -1. Okay, so let me take it back -1. So my original graph is this. Okay, my original graph is this. You can solve it algebraically as well. First of all, we will find f of x plus 3. Okay, what is f of x plus 3 graph? Which means x should be what? X should be replaced by x plus 3. Wherever I see x, I need to plug that x plus 3. Okay, in place of x, let's put x plus 3. Okay, x plus 3. I don't want to write a parenthesis. X in place of x plus 3, plus 1 is next to that, square, and -1 is there. Okay, that is f of x plus 3. If you simplify more, it's becoming x plus 4 whole square. Okay, -1. This is f of x plus 3, but plus 2 also we have here outside. So let me write it f of x plus 3, f of x plus 3 plus 2 separately, okay? Which means that f of x plus 3 is x plus 4 whole square minus 1 plus 2 is there also. I'm adding at 10. So when you write f of x plus 3 plus 2 function again with details, you have x plus 4 whole square, okay, and plus 1. So what is the vertex of this function? What is the vertex? Vertex of this function is at negative 4, positive 1, okay? Negative 4, positive 1, negative 4, positive 1, we got it already. So in two ways, algebraically, you can solve this question, or by transformation, by shifting vertically and horizontally, you can solve this question also, okay? So your vertex will be in the second quadrant, okay, in the second option. If there are A, B, C, D option, you can select it. I think in this question specifically, you can select quadrant 2. I hope you enjoyed the video. I hope you got the answer also. If not, you need to study transformation a little bit more. See you in the next video.